All right, before the break, we started talking about software a little bit, some random things thrown in there that are hopefully more interesting than just the technical terms on their own. Little side steps into stories about software development along the way, but in particular, machine language, assembly language, and then high level languages. And you'll have an assignment this week in high level languages. That's sort of stuff we would study as a software developer. Before we get completely away from assembly language, I want to look at a quick example of that. And then I have some very important terms as far as writing down, some very important terminology related to our languages, the categories they go into, and then some examples. And I'm trying not to go down, trying not to get super detailed. This week, software development is the thing that I teach most often. The high level course, software development courses. So I don't want to get too many details, but before we step away from assembly language, I would like to look at an example of that. So I'm going to open a little IDE. That's Integrated Development Environment. It's basically a place where we write code. It's a text editor. Sometimes I do refer to them as text. It's fancy text editor. So here's the one I always use for Python. Just because what I want to do is a little bit easier in this language. So I'm going to make a little function. We're going to look at an example here in a moment, but I wanted to look at something about assembly language so you can see a little bit of that. So I'm just going to make a little pre-built piece of code that we could ask for over and over again that just prints the words "Hello World" to the screen. That is a standard test. It relates back to a commercial in the early 80s, early Mac commercial. They turned the machine on and threw the words "Hello World" up. Y'all may have seen references to the commercial. But it has become the standard test. We always do that first thing because if we can print those words to the screen, we know everything's configured correctly. We don't want to do a bunch of complicated and complex things, have a whole bunch going on, and then figure out we have our configurations wrong. So we even call it that. So whenever we do, when we do more advanced things like machine learning, the hello world for machine learning, at least the visual one, is to recognize the digits. And we still call it the hello world. So that's become the standard. So I'm just going to print that out to the screen. Print hello world. Just a quick message. Whoops. Then this is just something we put in the language. I guess that part's not quite so necessary. And then I'm going to ask for that reusable piece of code. So this line here, that basically just tells the machine, if this is the file that we hit the run button on, then do this stuff. Whatever one we actually hit the run button on gets renamed. So if the name happens to be this thing, then we know that's where we hit the run button. So then we'll run the code just to describe what's going on there. So nothing too fancy here. I do have to save this in order to get to the thing I want. Yeah, Untitled is a good name. I don't need to save it as far as keeping it. I just need to save it for the next few seconds. So I run that code and we see that message pop up on the screen. But what is that? What was really involved with that? So I'm going to come over here and add some lines in here. And this is further than our examples are going to go. Our examples are simpler than that. I just want, this is the easiest way to get to assembly language. So DIS is a pre-built module or library, a bunch of pre-built code for us that we can use, we can ask for, and that the abbreviation for disassembler. So it takes our high-level language down to assembly language. See that? So before running that method, I'm going to write dis.dis and then wrap all that in parentheses. And then this has to run twice because it's not going to, the machine's not going to know what the assembly language is until after it's run once. So it has to run at least once so it can see everything that's needed. And no last trace back to disassemble. So there's nothing to look back at to see what it's done before. And now if we run it again, so let me clear out my console here and get where we can see that on there. I run that. Wait, let that not run. Oh, well, I shouldn't have cleared out the console. Sorry. So if I run that now, then we get something that looks like this. It's kind of behind the screen on the TV. Actually, I went to clear the console and I just closed it and opened a new one instead of clearing it. I do that a lot out of habit because that's quicker. I should have typed in the keyword clear because when I closed it and restarted it, that was restart on the software. So it wiped out that first run. But this is what actually happens when we ask to run that code. So loading something, and we're going to load in some sort of constant. We're going to make a comparison. So that's looks like that's down here. So we load, actually it goes the other way. So we load this thing with the two underscores. The two underscores at the beginning and end tell the machine that this is something closer to machine language than closer to human language. So that's why it's load fast. And then we load in this thing where we just directly type the value. We put quotes around it, so like exactly quotas on these characters showing up in this order. So it's going to load that in as constant. And then it's going to compare to make sure they are exactly equal, or those two things are the same. The one on the left is the same as the one on the right. So notice there's these keywords. Those are from assembly language. So we load a couple things in. We make a comparison. Jump if false. That example I wrote on the board earlier, we jumped on a carry bit. That's closer to the machine language that we've talked about. This gets a little more complicated. Jump off on false, and if it's false, then we need to go to line 64. So if we come down here to find load 64, basically that finishes up. You can see it's in this bunch of instructions down here, which basically just finishes everything we were doing, clears out RAM so that stuff can use it. But so if they're not equal, then just jump to the end of the program. Then we're finished setting things up. So we need to go to line from 10 to 20, which are these. So we're loading in some more stuff, setting up the values, we're storing some things in memory, or really store fast. We're pushing something onto the stack, the thing we just created and loaded into RAM. Well, we want to push that onto the stack so it actually runs, put that on the instructions that are actually running, and then we're going to jump forward after it runs. So we come down to line 30, where we load some more stuff, do this, load, we ask for the function, make some little adjustments, and now we're popping. That means take things off that stack of instructions. So stacks like plates in a cabinet. When we wash dishes, the last dish we wash is going to be the last one put in the cabinet, but it's at the top of the stack. So that's the first one we grab when it's mealtime. So that's how the computer instructions are handled. That last instruction we just put on the stack is going to be the first one that comes off. So we can just say, grab the next instruction because we know what we just put there. Then we jump forward to line 50, which seems to do the same thing again. And then automatically jump fast somewhere. But when we pop it off the stack, that pop on the line stack is a pointer back to line 20. So we pop it off the stack and then we run back up here. So you can see assembly language is kind of difficult to work with. We're jumping all over the place. We don't have the full instruction, clear cut, and nice human readable language. Because in nice human readable language, it's really this word here, print. We know exactly what that means. All that other stuff seems very, very vague and cryptic. But that's how we pull up the Python assembly language. If anybody wants to look at that and see Python code before. We will not go that far with our assignment in Python this week, unless you want to. More is always acceptable in my class. So the Python assignment is put together for people that there's some stuff in Python and HTML. It's put together for people that have never seen them before. So if you've seen them both before, more is always acceptable unless you're short on time. If you want suggestions, I can make some suggestions. Have you all got your writing files?
Yeah.
If you know how to write a file, my suggestion would be to combine those two and have your Python script write the HTML.
Yeah.
That might be a good example, but more is always acceptable. So I know you know both of those languages, so feel free to do more.
Yeah, part of it, I saw a challenge part for the file length, and I'm like, oh, dude, I don't know about that.
Yeah, more is always acceptable in my class. The instructions give the minimum of what's required for the assignment. So if you want to do more, if you already know the subject and want to do more, then do more. So that'll go for you, Hunter, whenever we get to the Linux virtual machines. Because you're sitting here working on the Linux machine, so you can do more than turn one on and run upgrade and install, or update and upgrade. And
Hey, VMs are always very different from having it on an actual machine.
yes. So if you want to do more is always acceptable. Just the instructions are the baseline. You have to do at least that much. But if that's if you've had 3 or 4 classes past that, or have been doing that yourself for years, feel free to go a lot more. So next thing is categories of software. And you'll probably notice that we're not talking about just generic software in general. We're talking about software development this week, the one we actually study in the field of IT. I keep leaving development off the list. So categories of software development we have. Categories of languages. Are programming languages. That's a good label for this. There's different ways that we can categorize them. The big 2 at the top of the list are going to be interpreted. Sorry, I have to spell that word. I have to spell it slowly, or I will not spell that correct. Never mind. I spelled it slowly and still spelled it incorrect. So either interpreted or compiled, and I'm going to write verses. So languages are either interpreted or compiled. Notice it's a one or the other situation. We're on binary state machines. So all of these categories are going to be one or the other thing. So interpreted, let me have a different color. So interpreted is line by line, one at a time. One at a time. And a compiled language is entire set of instructions all at once. I have a picture here. So, say we have a text file with a bunch of lines of code written in it. I'm just going to abbreviate it like this. Does that make sense? Lines of code in a file. So with an interpreted language, the machine will come in here. It'll grab line 1 and turn that into something the machine knows what to work with. I'll just write binary code 01001110 and so on, whatever that comes out the machine language. There's several layers of this. It can get a lot more detailed. So It probably wouldn't go all the way to assembly language, but to generalize the concept here, I'm just gonna write the assembly language. We turn it into something the machine knows what to do with. Then we come back and grab line 2. And we turn line 2 into something the machine can work with. Assembly language, bytecode, perhaps machine language itself, depends on what we're doing, but we do it one line at a time. We start line 1, run that, come back, get line 2, then run that. So one thing, an interpreted language will start running and then crash when it hits an error. A compiled language, so we'd have a text file with a bunch of lines of code in it. But instead of grabbing one line at a time, we grab that whole thing and turn that into a file of something the machine knows what to do with. 001100101 ... And we have this entire file of something the machine can work with. So a big difference there is the error messages. I said this one will run up until it hits an error. It'll start, and then unless the error is in line 1, which is still kind of the same thing, but it'll start running and crash when it hits an error. This one, we won't be able to turn it into something the machine could understand or compile it if there's any errors in there. So we get the whole thing all at once. Had a marker cap, it seems to have completely disappeared. So the next category, I guess there's enough here to write it. Imperative. Not with that marker. Try one of the other ones. Oh, this is the one that squeaks. The tip is loose, so it is pushing in and out. Maybe if I try to write very softly. Imperative versus declarative. So an imperative language is explain how to carry out a procedure. Explain how to carry out task. And a declarative language is a bunch of the task that it's set up to create are already programmed in. So tasks are already created. We just ask for the ones we need. Or ones we need. So an imperative language is used to create a declarative language. So for example, imperative is how we step by step tell the machine what to do. So that's what we normally think of as programming languages: C++, Python, R. The list would go. There's a long list of those. Java, a huge list, but what we normally think of as a programming language, that would be an imperative. We have to break it down. We have to tell the machine, do this same thing 15 times with a slight adjustment so that we can figure out what goes in, do that. But a declarative language, they're already built. So SQL, that's structured query language, the language we use to work with databases. It's all of the functionality we need is already programmed in there, and we just ask for the one we want. Encoding things like HTML, I want to make sure that's on this list so that it's there. Bash, I'll put that here. There's a lot of overlap because we can start from scratch with bash, but what most people do, that's the operating system control language used on Linux systems or others. Mac used to come with it. Mac switched to ZSH. My Windows machine is set up so that when I'm not in a class example, I control it with a bash shell. But we can give it step-by-step instructions, but what most people do is the pre-built instructions, like touch and cat and IP address and things that are already built, and we're just asking for the ones we want in a particular order. There's a lot of overlap. So those can show up in other places too, because SQL would be an interpreted, like SQL and Bash would be an interpreted language. HTML is a compiled language. C++ and Java are compiled, Python and R are interpreted language. So there's overlap between these categorizations, but they do come in binary states. That's an important thing to take note of. When we start categorizing our languages, they're going to be one or the other. And I just used this word a couple times, but the next categorization would be scripting or programming. There used to be a big technical definition distinction between those two, like 25, 30 years ago, before most of y'all in this class were born. Not so much anymore. They're kind of, we use them as synonyms. Generally, scripts refer to smaller things or stuff that would not stand on its own, whereas programming is used for really big things. But they're generally synonyms anymore. The distinction between those two words was done away with in the 1990s. Versus encoding. So scripting and programming, that's perform actions. And encoding is like format data. And very common task. I'll put that on there as well. So things that we're going to do over and over again, day after day after day after day, like log in. Okay. We don't have to go write a script and tell the computer how to do a login. That's built into pretty much every machine these days. So we can just encode something we can encode that part. C++, Python, those would be scripting programming languages, the traditional thought of that. Whereas HTML would be encoding. SQL, well, actually, this one splits up. So like SQL would be a scripting language, because we're going to put those declarations together in a different order every time, depending on what we want to get from the database. Whereas HTML is pretty much always an encoding language, because what we do for that is set the format of our data. We define how it's going to show on the screen. Obviously, there's a lot of overlap in these categories, but the important thing to note, the words written in black are all keywords that you're going to need to know for quizzes, not just in this class, but as you progress through IT and talk to different people how to use them. The important thing to note is notice they always come in pairs. It's binary state machine, and anytime we use one of these words, there's another one that goes along with it. So not just the words and what they mean, you want to remember the pair it's part of. Because it wouldn't make much sense to try and compare compiled with encoding. Because some encoding languages are compiled. HTML is compiled and encoded. So it wouldn't be a comparison. Whereas R is interpreted and scripting. So comparing across that wouldn't be a good comparison. That's jumping into different categories with things belonging to both of them. So high level languages made up of usually a short list of keywords and symbols that an interpreter or compiler will know. And then a bunch of pre-built code. And then we can use those keywords that the compiler knows and a few things, like it would know what a number means. It knows what to do if we give it a character. Under special situations, we have to put quote marks around a character so that the machine knows that that's not part of a variable or not a value we want to pass in. But there's some keywords and some pre-built code, and that's what makes up a programming language. So for example, Python. If I come over here to my computer and go to where Python's installed, which is on the C drive, and it's in hidden folders. So if you have Python on your machine and want to see it, you do have to go in and turn on hidden folders, which I think is Control-Shift-Dot. Oh, Control-Dot? Nope, that's not it. If you go to Options, under View, there's a little checkbox for Show Hidden Folders. If you go to the C drive and Users, and whatever the username is, there's a folder called @data, and this one will be hidden. And that folder is local programs. There's a bunch of them. And in programs is the Python folder. So if we go in here, so here's where Python's actually installed. Down here is this application python.exe. That's the actual executable that runs. That's our Python interpreter. That's the thing that knows what to do with certain things. And when it knows, then we have these other folders, in particular this one called libs, or an obvious abbreviation for library. Oh, whoops, not that one. No, libs, the singular one. The obvious abbreviation for libraries. This is a bunch of pre-built code. So what the compiler really knows is a few symbols. So it knows the digits, plus, minus, an asterisk for multiplication, 1/ or 1/ or 2 forward slashes for division, depending on how we want to do that, and different ones there. And then what's in this file right here? There's a file called keyword. Whoops, I didn't mean to run that. I meant to open that. So if I open that with a Sublime text editor. So what this is just a list of the words that the Python interpreter knows. And you will notice it starts on line 19 and only goes to line 53. It's not a very long list. 53 minus 19 is what? 34? There's 34 items in there. There's 34 keywords that the Python interpreter knows and a couple of symbols. And that's the part, those keywords and a couple of symbols are what can be turned into assembly language. But what we call the programming language includes all of these files and folders here, not just that one keywords file. So for example, if I was to go in calendar, this is one I often look at because it's not as bad as some of them. Some of them are really hard to follow. But what we call the language is all these other files and then folders filled with files that somebody already used those keywords to put together some Python code that we can ask for. So like for a calendar, bunch of stuff there. We could ask for the days of the month. We'd ask for the month. They're already built into the language, basically, because they're written in this other file that's installed there. Somewhere down here, this one. So there's this pre-built code we can ask for from anywhere in Python is leap. And we just give it a year name. So say 2023 is leap. Should return false. Somebody just went in here and wrote up the conditions. If the year is if we divide the year by 4 and there's no remainder, so the remainder when we divide by 4 is 0, and when we divide by 100, there is a remainder, so that means the centuries don't count, because centuries would normally be divisible by 4, but we don't want to count those unless unless we divide by 400 evenly. Then we'd have a leap year. So somebody already built that into the language. So our language is mostly things like that, pre-built code that we can ask for from that very short list of keywords. All of our programming languages are like that. It's just a little bit easier to look at in Python. So we would use those to look at things. And that's not something you necessarily need to know. You can write lots and lots of Python code without necessarily knowing what's going on internally. That list of keywords, if you plan to program in Python, you probably need to know what those 34 words are. But that's not very many words to memorize. And if you're studying software development, those are spread. Really, those 34 words are spread across 3 classes. You learn in detail what to do with each one of those, and along the way, learn a whole bunch of that pre-built code. And this week, that's what our lab is, to go write some code. So some of y'all are probably beyond this. Feel free to do more. Let's look at these. Oops. Let's look at the assignment. And I copied and pasted this assignment from an earlier shell. So there's different places where we can write our code. Look at the assignment first, and then we'll look at where I would actually recommend writing this, because I can't remember if I actually put it in the course shell, or I can't remember if I put it in those instructions or not. So in module 4, the software development lab, I copied from somewhere else. So there's an HTML page. If we look at that, it walks you step by step through some code to make a simple web page. I have no idea who wrote this, because I thought I knew at one point, but then when I said something to them about how I copied it, they said they copied the assignment from somebody else. And they were pretty sure that the person they copied the assignment from copied it as well. So at least around Ivy Tech, nobody's quite sure where this assignment originated from. But we're pretty sure it was written for Ivy Tech Community College. But a simple web page to introduce yourself. Everybody's guess was that it's somewhere near Chicago, because they used the Cubs logo for the thing. So probably somebody up in the northwest corner of the state, but hard to say that for sure. And it steps you through while writing that code. And same thing for a small Python example. Very introductory. So if you already know HTML and some Python, you know a lot more than that. Oh, okay. So the Python example does use this online IDE, and that online IDE will also work for HTML. So I would recommend using that one for this. It's repl.it is their old address. They updated their address, so now it's replit.com. It was originally made by Czechoslovakians, where the E is pronounced different. So it's the people that created it pronounce it Ripple, because that's what REPL spells in Czechoslovakia. But I've heard Americans pronounce that lots of different ways, and everybody seems to know what they're talking about. I would have, when I first looked at the word, I thought I would have gone with repel, and was very curious why it was supposed to be pronounced Ripple. And then it was like a year and a half before I learned it was created originally by people from Czechoslovakia. So, but it's an online IDE. If anybody's used VS Code, it's built with the same framework as VS Code. It's just that VS Code is kind of the default version, and they did make lots and lots of improvements for this one. So I should log out. Well, if you don't have an account, you'll need to set up an account, and then each piece of code is called ripple or repel or however you want to pronounce that word. Because we speak English, not Czechoslovakian. So that ripple is not what we think of when we look at that word for most people. And you'll notice right here at the top, it's on my short list. There's Python and HTML are right here. I have to scroll down, but this thing knows a lot of programming languages. C++, Node.js, C, Java, Bash. It knows variances of Python. So if you're interested in game development, it knows Pygame already. And several other game engines already built in there. Lots of nice things. React, that's very popular. Go is a programming language Google has been trying to promote lately. But like the last time Google tried to promote a language, before they started trying to promote it, they created a translator so that people could type in other languages they already know, and then it will automatically translate our text file into that other language. So the promotion hasn't been going so great on it because people, because they created a translator into that language first, and people learned about that, so they tried in the languages they know and translate it. But you can see there's lots and lots of languages here that this knows about. So if we want to write Python, we can go here, just choose the language. It'll generate a name, or you can give it some good name. This is a really nice one in classes. I like to show this to people for like asking questions, because it's a cloud-based app. So we have those normal things that we do, like invite and multiple people can work all at once. So like if I was to create a join link here, copy that and put that in the chat room. If you wanted to, you could come in here at the same time, and then multiple people can work on it simultaneously. And we have all those features like we're used to for cloud software, or like Google Docs, right? You can chat room, multiple people can type at once. And you notice before there's any code, there's a link with example. Oh. I was like, what? I already saw everybody who was here that I was expecting. I was like, who's here? I didn't realize it. Forget about that. Yes. So I might have to paste that in the chat room again. That's all right. There we go. So there's the link. Thank you. It makes it much better when we can actually point at things. So when it's blank, there's examples here, and there's links to tutorials and everything. After I close this, I'll kind of go back to the other one. So you can see she logged in. So if I click on that, or there's a chat room right here. Normal chat room stuff, or multiple people can type at once. For the world, I'll just do the standard example. But since she's logged on here, she can do that same thing, or come over here to the chat room, and Zoom buttons are in the way. Chat with multiple people, work on the file at the same time. All of those things that we're familiar with. Where's that underlined? Oh, white space matters in Python. That was one of the things they did to make it easier for humans to read. I couldn't even tell that was, with no other code, I couldn't tell that was indented. Because other languages use like semicolons, that means end of instruction. Technically, it means next instruction because the computer reads the code backwards from what we write it. So technically it means next instruction, but from where it goes in the text file, now that technicality has been mentioned, we're always going to think end of instruction when we type a semicolon and curly braces, and forgetting those can cause big problems and they're hard to look for. So we thought white space would be good, but looking for a missing curly brace, a big symbol on there, is nothing compared to like looking for the missing white space. That can be quite a headache at times if the white space is off. Okay, yeah, so our cursor's in there now, so you can see that, the chat room. So that's great for homework. like in software development classes, whenever somebody has a question, sends me a question, a lot of times we'll jump on here and look at the code so we can edit at the same time, have the chat room and all of that functionality. And you don't have to download the file. Whoever wrote those instructions, pretty much every set of instructions I see that were built for Ivy Learning, they always say download the file from the thing. There's a share link right here. So if you do it here, you can just submit the share link. And this will work for both the CSS and the HTML. And Samuel's in there now, so several people are in there, work together. It's a really, really useful thing. Multiple people editing, which we often do software development as projects. And classrooms are under tight time constraints, so obviously things have to fit in those time constraints, so we do small things. There's usually at least one group project where we write code together. So things like that are incredibly useful. Lots of other tools built in. Oh, I should hit the run button so we can see that. Run it and get the console there. There's also a bash shell. It's running on a Linux server, so we have a bash shell to run it. So I could just run it from here and say Python and main.py if you like to do things from the terminal instead of the shell that knows the language. Set up virtual environments and all of the terminal sort of stuff we would need to do. We have our own little personal virtual machine running on that server. Their server is set up so it automatically clones itself and makes smaller versions of itself, and everybody that logs on here gets their own version. So we have full control over what's going on that machine. Chats, threads, it links directly to GitHub repositories. We'll talk about that soon. So you can set all of that up. Over the summer, there's a special topics course running in software development, specifically on GitHub. It's going to be a new course going forward. I took it to the committee last year and they voted to include it. So I wrote up all the catalog description and major learning objectives and all of that stuff. And I want to give it a test run before I go back and actually submit that to the committee that's been approved. So over the summer, there's a special topics course running specifically on GitHub, if anybody's interested in that. It's SDev 193. But you'll see there's lots of other tools built in here that we can use, as well as monitoring the machine we're running our code. Taking telemetry. Telemetry or profiling would be the terms we use for that. Like how much RAM do we use? That can be important, right? Because the computer only has so much RAM. We don't want to use too much because there's also lots of other programs trying to use RAM at the same time. So all the tools we need are there. So there's the Python one. I'm going to jump back over to my account. You can see there's lots of files, and if you want to download them, there's a download button right there. You can download all the relevant files as a zip folder or click the three dots and download the files individually. Create new files and add more to connect into a big project. So it's a very, very powerful, fully functional IDE. Everything you need to write your code and develop a program's there. Where's the button to get back to my account? I'll create a new one. So I think this will just switch the page out. So in HTML, it also comes with a pre-built HTML. The HTML template doesn't start blank. So they gave a whole bunch of blank code, but for those instructions on the step-by-step lab, if you're following that, just delete this code and start with a blank file. And you can do it right here. And again, when you go to submit it, you don't necessarily have to download the file. You can just go over here and generate a share link and then submit the share link. That's a much more normal way to share files in 2023 than downloading a copy of it and uploading a copy to Ivy Learning. Just send me the link to it. That's sort of the whole point of, that was one of the main points in the internet that really made the internet take off in popularity. was, we don't need to send our data. Instead of transmitting a whole bunch of data across the internet to you, how about I just transmit where do you find that data? And then if you want it, you can go get it. That was the idea that really took the internet up, made the internet take off, the hyperlinking. That's what the H stands for in HTML. Step-by-step instructions. There's lots of these things. Ghostwriter. So there's a chatbot built in here if you want something to type your code for you. If you want to just tell it the algorithm you want and let it type up, there is a ghostwriter. Still in the works, but it does pretty well. How do I get back to my account? Here we go. There's a learn tab. So tutorials are built right in here. Click that learn tab and drawing with code. So actually using code to draw, that is really, really fun. It's very, very time consuming, but I have lots and lots of fun doing that. If you want to do that in Python, Grace, I have some instructions I have some labs set up for that aren't necessarily step by step. They just hint at what you need. But all sorts of tutorials are built right in here. So you don't even have to go look for stuff. Drawing images, there's game tutorials. It knows Bash, so there's an introduction to Bash, and we have access to that Bash shell on the server if you want to learn about Linux servers. Steganography, some big words. So sockets. Sockets are better connections to a server. So instead of just like an IP address where we can go in a web page, we make a dedicated connection to a server so we can do things like stream video games. Lots and lots of things, but it has the learning built in right there. There's a huge community thing, so there's a social aspect to this as well. Has lots and lots of tools that we need, so I would recommend doing both of the projects here. Maybe click around, click on that Learn tab if you're interested. Try out some of the features, see what's there. There's a lot of stuff in there, but it's hard. It is a place to go write code. I guess I have to go in here and let's see if I can find that one I was just on. 1 year ago. I really need to clean this out. Did I not save that one I was just on? I didn't look at the name. Unnamed, so it's probably in there. Oh, 11 minutes ago, I bet that's it. I don't know if y'all are still logged on to this one. I assume the one from 11 minutes ago is the one that was just there. Yeah. So this is a great place to go work on those coding assignments and a good one to be familiar with in general. This might be something you need there. Yeah, documentation is included right in there. If you know what repositories are, there's this is already linked to your repository. Lots of things. That is my recommendation for where to do that. Or even if you have another place on your computer to write code, like maybe you've done that before or have something you like and it's not necessarily new, at least check that one out. There are some really, really useful features. It's one of the nicer IDEs out there. And that finishes up what I had on the notes to talk about it. And I don't think I went down too many deep rabbit holes. I did get distracted a couple times. But the terminal, it's an introduction. It's a vocabulary class, just getting started. Remember, one of the biggest things from this class is the survey aspect. Every week we're looking at basically what's a different program here with the School of IT. The hardware is IT support. Then we looked at data. There's data analytics program. This week's software development. That's software development and cybersecurity seem to alternate between the biggest programs. And those two programs across the state and all the Ivy Techs are about 95% of the School of IT students. People want to do software development or cybersecurity. and it alternates every semester, which one's slightly bigger than the other, and usually not by much. But they're programs, so as we go through this class, we look at a different one every week and make sure you're in the right one. Happiness is worth a lot, so make sure the program you're in is the part that really interests you. Or if you're not quite sure what you're looking for, informatics would be the broad spectrum one, where we study all the different fields and then put them together to make it useful and applicable for businesses. So if you just want to do everything about computers in general, that would be informatics, sort of the whole course. Otherwise, just pay attention each week and see if you feel like you're in the right program, or if one of the other programs interests you enough to change to the other program, or even assign it as a second degree and get 2 degrees instead of 1. Right? The traditional saying 2 is better than 1, almost always. And if you have 2 degrees listed on your resume, that's going to look a lot better than if you have 1 degree. You have multiple expertise. So the big thing with the software development, go through those labs and see if that interests you. And if so, you could add software development as a secondary degree, or if that's your primary degree, confirm that that's what you're interested in, or maybe give you one more option to look into. Anybody have any questions about that? Okay. I see head shaking no. I'll give it a couple seconds for those on the Zoom call. On Thursday, I want to talk about a very specific piece of software, operating systems. There used to be a course covering operating systems, but when they revamped the School of IT into its current format, there's no longer a course that covers operating systems specifically. So I want to talk about all the different pieces of an operating system and how those pieces go together and how they tie everything together, because it's not really covered anywhere else. I'll do that a couple times this semester. When we get near the end, I'm also going to talk about graphics, because, well, if we have the picture format, we just use it. So it's not, the details aren't really covered. Graphic artists don't even get into the details of how internally, down at the machine language, like we've talked about a couple times, what's the difference between a JPEG and a bitmap, or JPEG and a PNG? What is that difference? So I like to cover that because it's not covered anywhere. Thursday's one of those days. Operating systems explicitly are not covered in any courses, so we're going to talk about that on Thursday. And depending on how that goes, we might get started into networking. So, and after that, I will make the decision on whether the course next Thursday on April 20th is going to be virtual from my hotel room up in Indy, or if it'll just be canceled, depending on how far we get on Thursday. Either way, it'll be a short class if it's virtual, but that's still a week away, and I'm not sure if I don't want to cancel it. 8 weeks is not very long. I hate to cancel a class. But otherwise, that's been time to see if anybody had any questions to ask them. So I assume the silence means no questions. If you have any, let me know. I'm always happy to help. You all have a great day. I'll see you on Thursday. A great evening. I guess the day's almost over now, isn't it?